Law of cosines has a long formula. There's the standard form when you're trying to find a side length. And then there's the alternate form, which you're trying to find an angle measure. You will be given both of these on the quiz or the test. All three of the formulas are the same. It just depends on what side versus angle you're looking for. But in the standard form, whatever sides are given, you square them and add them together and then subtract the product, God bless you, of the two sides multiplied together times 2 times cosine of A. But again, you guys are going to be given these formulas. You'll also be given the law of sines, but that's easy. It's just law sine A over A, whatever. So when we are talking about law of cosines, there's going to be two instances, two situations where you're going to use the law of cosines. It's always easiest to use law of sines, but in order to use the law of sines, you have to have an angle and its corresponding side length. In the two occasions that we're going to see here, the reason you have to use law of cosines is because you don't have that information. So what you end up doing is using the law of cosines for the first step and then using the law of sines to solve the rest of the triangle. Now there's two different situations. There's one where you're given all three sides, and there's one where you're given two sides and an angle. So there's different ways to solve each one in order to get the correct answer. And I'll show you right here, write this down. If you are given all three sides, you have to find the largest angle first. Because yesterday we talked about there are cases where you could possibly have two triangles, correct? So there could be, doesn't happen all the time, but there could be situations where if you don't go in this order, you'll find a triangle, but not the one that you're supposed to find because it was an ambiguous case and there was one hidden or something like that. So if you just follow these steps, you'll always find the correct triangle that you're looking for. But if you are given three sides, you have to find the largest angle first, then you find the smallest angle. That's the way to solve it. Find the largest angle, I should say, and then the smallest angle. Now, if you're looking at a picture like this, right? Pictures aren't always drawn to scale. How do you know what the biggest angle is? It's across from what? The longest side. The shortest side is across from the smallest angle. So remember that. You always want to remember that ratio. So if we're going to find the largest angle first, and we're going to use the law of cosines. All right, so which one is the largest angle? B. So that's what we're going to solve for. We're going to solve for angle B. So look at your alternate formula. Look at your formulas. Are we going to find a side or are we going to find an angle? We're going to find an angle. So let's use that cosine B formula. Do you guys see that? So, all right, cosine B, correct? Read the cosine B formula to me. Cosine B is what? A squared plus C squared minus B squared over 2AC? Yeah. Thank you. Now, why are we finding B? Because it's the biggest, okay? So we're going to find B. Now, all we do, guys, is plug in all of the information. So what is A? What is side A? 8. So we have 8 squared plus, what's C? 14 squared minus 19 squared all over 2 times 8 times what? 14, okay? If you want to do the numerator all in your calculator, that's fine. Go ahead, throw it in there. Say 8 squared, because you guys have your calculator, plus 14 squared minus 19 squared, and you get what? Negative 101 over, what's 2 times 8 times 14? 224, okay? So you guys just found out that the cosine of angle B equals negative 101 over 224. And you're like, wait, what? I'm trying to find an angle measure. Is that the angle measure? No, what is that? That's the cosine of angle B. How do you think I figure out what angle B is? Second cosine, correct. Remember, if we're finding angles, we hit second. So we're going to hit second cosine and then put in negative 101 divided by 224. And go ahead and round to just one decimal place is fine. We get that angle B is 116 degree, 116.8 degrees. Okay, perfect. So I'm going to write that right here in my triangle. I know angle B is 116.8 degrees. You guys okay with that? Now, the next step, you are more than welcome to use the law of cosines again if you want to, but you don't have to, because do we now have a side and its corresponding angle? Yes, so we can use the law of sines. We can go ahead and write, oh, I know that the sine of 116.8 over 19, I can set up a proportion, but what do I need to find? I found the largest angle. What's my next step? I need to find the smallest. So which one am I going to find? A, good. So I'm going to say sine of A over 8. Now, the reason why you have to go in this order, guys, is because, remember, yesterday we talked about the ambiguous case. Not all the time, but sometimes there is a second triangle present. So if you do not go in this order, you might find the second triangle, and that's not what they're asking for in this case. They're asking for what goes with this triangle, not something else that is present. So you have to go with the largest and the smallest. So we're going to go ahead and cross multiply. 19 times the sine of A equals 8 times the sine of 116.8. And then I'm going to divide both sides by what? 19. So now do all of that in your calculator, and you're going to get some sort of a decimal. You guys get 0.3758. All right. Is that the angle measure? No. What is that? That's the sine of the angle. So go ahead and hit second sine. And if you have that decimal or that answer still above, you can hit second answer. And you'll find out that angle A is how much? 22.1 degrees. Okay, so angle A is 22.1. So if I know B is 116.8 and I know A is 22.1, how can I figure out that missing piece? Add the two and subtract from 180. So you go ahead and say, okay, I have 116.8 plus 22.1 is what? What is it? 116.8 plus 22.1. 138.9. Okay, and then I subtract that from 180. And I get what? 41.1 degrees. Okay. Now, every time you guys use the law of cosines first, you should always go back and do this one thing. What did you tell me at the very beginning? How did you know what the biggest angle was? It was across from what? The longest side. If for some reason you go out of order, you could possibly get the right answer if there's only one triangle. But if you go out of order, you didn't do the largest and smallest, whatever, you can check to see if you made a mistake. Because if you go out of order and there are two triangles present, the longest side won't be across from the biggest angle. It won't, the proportions won't work out. You always should look to see, okay, 116 is the biggest angle. Is it across from the longest side? Yes. The smallest angle is 22.1. Is it across from the smallest side? Yes. And this is the medium one, right? So if for some reason you go out of order, you should go back and check and just make sure that this is across. Because if you went out of order and there's two triangles, that proportion won't match up. The longest side will be across from like the smallest angle measure. And then you're going to be like, wait, something's wrong. And it's because you went out of order. Does that make sense? Like kind of a way to check? Okay. All right, look at the next example here. You're given two sides and an angle. So this is a little different. In this case, you have to find the missing side first, which would make sense. There's nothing else you can do. But then you have to find the smallest angle. So in both cases, the second step is to find the smallest angle. If you think about it. And when you're given three sides, it's largest, smallest, medium. When you're given two sides and an angle, it's find the missing side and then find the smallest. Because in order to use the law of sines, you have to have a side length and its missing and its corresponding angle. We don't have that here. What we do have is two sides and an angle. So which formula would I use and what am I looking for in this case? Where would I begin? What am I looking for? What does it say to do? Find what? The missing side first. So what is your missing side? A. All right, so I'm going to use the formula that says A squared equals. So I have A squared equals B squared plus C squared minus 2 times B times C times the cosine of A. Again, this is just plugging in your calculator. What is your B value and what is your C value? So 9 squared plus 12 squared minus 2 times 9 times 12 times the cosine of 25. Now, if you do all of this in your calculator, you will get the right answer, but you got to just make sure that you key everything in correctly. You have all your parentheses correctly. I would suggest you do this part first and this part separately and then subtract the two. What is 9 squared? If not, sometimes you guys get really crazy with your parentheses and then it's tough. So 9 squared plus 12 squared is what? 225. Okay, so 225 minus what's 2 times 9 times 12 times the cosine of 25. 195 point, just write it all out, 76248. 2. You guys aren't always going to be exact. You're always going to have to round. And then what do I do with those two numbers? Subtract them, okay? So 225 minus 195.7624, 29.237518. All right, did you find the side length? No, not yet. What do we have to do here? You got to take the square root. It's A squared. So take the square root and then round to 1 decimal place. About 5.4. How come, guys, this isn't 5.4 meters? How come I don't have plus or minus? We're talking about length, right? We're talking about length, so we don't want to have negatives. We're talking about length, so we don't want to find negatives. All right, so what do you guys know about, since 25 degrees is A and 5.4 is side A, what's the smallest angle in this triangle? A, right? So according to what it says to do, let's find the next smallest. We're going to go in order here. So what would be the next one to find? Let's find angle B. Why do you know B is going to be our next in line? Right, because 9 is the medium side, so you're going to find angle. So I have my proportion of sine 25 over 5.4 equals sine of B over 9. Yeah? So how do we solve this? How do you solve a proportion? Cross multiply 5.4 times the sine of B equals 9 times the sine of 25. Divide both sides by 5.4. And what's the sine of B? So 0.7043. Okay, and again, that's not the angle measure, right? That's just the sine of it. So what is angle B? Hit second sine. 44.7, okay. So 44.7 degrees. So angle B is 44.7 degrees. That's our medium size angle. So what do we know about this side, the measure of angle C? It should be bigger than 25 and 44, correct? We're going to add 25 plus 44.7. Was that what it was? All right, what is that? 25 plus 44.7. 69.7, and then we're going to subtract from 180, and you get what? 110.3. So this is 110.3 degrees. Now check, is the smallest side across from the smallest angle? Yes. Is the largest angle across from the longest side? Yes. So you're good to go.
Can you have found C before D?
In most cases you can, but just so you don't, yeah, it's just so it's not one of those ambiguous cases. It's just easier to go in order. I guess we could call this the smaller angle, not the smallest. Because in this case, that happened to be the smallest. All right, let's go along. We have 2 more things to do. Pitcher's mound on softball field. I did not make this up. This is from the book. But is 43 feet from home plate. The distance from the bases is 60 feet away as shown in the figure. How far is the pitcher's mound from first base? So this is what we're looking for. How far is the pitcher's mound from first base? So what information is given to us right now? No, we're not. Sorry, I put my X in the wrong spot. We're looking for this right here. What are we given? We're given 2 sides and an angle, correct? So what do we have to find first? The missing side. It doesn't matter what letter you use, guys. You're finding a missing side, and you're finding, so just pick one of the formulas to use. What do you want to use? Go ahead and designate what side's A, what side's B. If you want to say, look, you want to say this is A, this is B, this is C, whatever you want to do. You want to use the A squared one? Okay, so A squared equals B squared plus C squared, right? Yes? Okay. Minus 2BC cosine A. Okay. So let's plug in. Does it matter which you designate B, which you designate C? No, it does not matter because you're adding the 2 together, squaring them, and then you're multiplying. It does not matter. But according to how I wrote this, I'm going to say this is 43 squared plus 60 squared minus 2 times 43 times 60 times the cosine of what? Cosine of what? 45, okay? So again, I like to do this in pieces. So what's 43 squared plus 60 squared? $5,449, okay, minus, and then I have 2 times 43 times 60 times the cosine of 45. What'd you guys get? 3,648.6709, we'll say. All right, so now what do I do to those 2 numbers? Subtract. And I get A squared equals 1,800, excuse me, 1,800.3291. All right, so if you stop there and you say, oh, okay, from the pitcher's mound to first base, it's 1,800 feet. Does that even make sense, guys? No, that should set off an alarm in your head like, wait, I forgot to do something. What did we forget to do? Take the square root. So you take the square root of both sides, and about how far is the pitcher's mound from first base? About 42.4 feet. All right, that makes a little more sense, yeah? You always want to check your answers, especially with word problems, and make sure that they make sense, mathematical sense. All right, we talked about area of a triangle, base times height divided by 2 with a right angle. We talked about the sine formula when you have 2 sides and the angle in between. You say the 2 side, A times B, right? Sine of C over 2. This is something called Heron's formula. You guys will get this. But Heron's formula you use when you have 3 sides of a triangle. You can't use the other one because you don't have an angle measure. All you're doing, you have to find this value first. A plus B plus C divided by 2. I need you guys, though, real quick. Just to see how your calculators work, because you guys are all using different calculators. I want you to evaluate both of these. Do the first one exactly how it's written, and do the second one exactly how it's written. Here I got 16. And here I got 11. I just did the exact same problem in my fancy TI-84, and I got 2 different answers. Why are the answers different? Yes, order of operations. What you have to do is add the numerator first, then divide by 2. If you do not tell your calculator to do that, if you do not tell your calculator with parentheses, hey, add this first, then divide. What your calculator is going to do is divide right here, the last number by 2, and then add 10 to it. Because think about it, in order of operations, division comes before addition. So don't tell me that your calculator's broken. You guys remember, the calculator's only as smart as the user. You have to input the problem correctly. And if you want to just add the numerator, hit enter, then divide by 2, you can. But if you want to do all of this at one time, you have to put the parentheses around the numerator to tell your calculator, add this first, then divide by 2. Oh, some calculators, yeah, that's why I said some will, some won't. It just depends. All right, so this formula is super simple. You're going to find the S value, and then you just plug it in here. You say the square root of S times, and then you subtract each side from the S value. So watch how easy this is. All right, here's your problem. It says find the area of the triangle. Why can't we use the sine area one? There's no angle given. So the first thing we have to do is say, okay, what is our S value? So we take all 3 sides and we do what? You add them up and divide by 2. So let's go ahead and do that. So 53 plus 72 plus 43, and then divided by 2 is how much? $84. Perfect. Yep. So you're now going to take your 84, put it underneath your radical, and then you're going to take 84 and subtract every single side length from it. So 84, doesn't matter the order, minus 43 times 84 minus 72 times 84 minus 53. And then we're just going to simplify, guys. I'm going to keep my 84 here. What's 84 minus 43? 41, okay. What's 84 minus 72? 12. What's 84 minus 53? 31. All right, now we're going to multiply all those numbers together. So 84 times 41 times 12 times 31 is a big old number. You guys with me? And then what's our last step? Take the square root. What'd you get? Say it one more time. 1,131.8. All right, we're measuring in meters what? Squared. Now, guys, on your test or quiz, you're going to say, do I have to show all my work? I absolutely have to see at least this first step. Don't just put everything in the calculator and give me an answer. You have to show your work to support your answer. If you put this on your paper and then go directly to this, that's fine with me because you did everything in your calculator. But I at least need to see that first step to see what you put in the calculator. Does that make sense? Okay. Just make sure you guys do that. And then this is just the area formula. It's just going over the 3. We're not going to have any with the standard formula because we're not talking about right triangles. We're talking about just oblique. So you'll have an oblique triangle and you'll have Heron's formula, but you're not going to have any right triangle ones. So go ahead. You guys can start your WebAssign now. You have tomorrow in class to work on it. And then I'm going to give a quiz review tomorrow. You guys can work on as well. We're going to go over the quiz review, just talk about some things that are going to be on the quiz, and your quiz will be on Monday.